Welcome to the Comp2140 walkthrough on 2-3 tree insertion. What we're going to be doing is we're going to be inserting a sequence of values into a new empty 2-3 tree. Now, since the tree is empty, our initial root node is going to be null. So the first value we insert, 50, is going to require a new node be created for it. And that's going to be both the root of our tree and the only leaf node contained in our tree. Now the second value we insert, 60, is going to be inserted at a leaf, and since there's already room for the value 60 inside of this node, we're simply going to add it to the existing node. Now the third value we insert, 70, is not going to fit in this node. So when we try to insert it, we're going to be required to perform a split. Now in this case, because the node is also our root node, the split is going to require the creation of a new root node for our tree. Now we're going to take the middle of the three values that we've inserted, so in this case 60, and push it up into the new root node of the tree. The value to the left of it is going to, in this case, just stay where it is because it's going to be the left child, and the value to the right of it is going to be moved to the right child. The next value we insert, 40, we're going to look for the correct leaf node to insert it into. Now since 40 is less than 60, it's going to be on the left of this node, which means that we're going to try to insert it into this leaf node. Well, as it turns out, there's room for it. So all we have to do is add the value to that node. The next value we insert, 30, is also less than 60. So we're also going to try to insert it into the same leaf node. However, in this case, there's not room for it. So what we're going to need to do is we're going to need to take, again, the middle of the three values and push it up to the parent. Now in this case, the parent only contains one value, so we don't need to perform a split like we did before. Instead, all we're going to need to do is move the value 40 up into the parent node. Now the value on the left, the smaller value, again, is going to be the left child, and the value on the right, the larger value, is going to stay as the right child. So 40 gets moved up into the parent. Just redraw this a little bit to make it neater. And there we go. Now, pause for a second and take a look. As you can see, at any point in this insertion process, we're always going to be left with a valid 2-3 tree. So in other words, here, the leftmost child, 30, is less than the value 40. The value 50 is in between 40 and 60, and the value 70, the right child, is greater than 60. The next number we insert, 20, again is less than 40, so it's going to be going in this child over here. Since this is a leaf node, and since there is room for it, we can simply add the value 20 to this existing node. For the next value we insert, 10, well, once again, 10 is less than 40, so we're going to be inserting it into this node as well. But once again, in this case, there's no longer any room for it. So we're going to have to take the middle value of the 3 and try to push it up. Now, as we can see, there's not going to be any room for it in the parent, so this is going to require a little bit more work. So let's take a new node here that's going to be the left child. it's going to contain the value 10. The value 20 is going to get pushed up into the parent, in this case the root, but there's not going to be any room for it. Now, since this is a root node, and since we're splitting the root node, it's going to require the creation of 2 new nodes. So the first of these 2 new nodes is going to contain the value that's the smallest of these 3 values, in other words, 20. And the middle of these 3 values is going to get pushed up into the new root node of our tree. So 40 is moved up into the new root node of the tree. Its left child will be 20, its right child will be this node containing 60, and then 20 will have left and right children, 10 and 30. All right. The next value we insert, 80. Well, 80 is greater than 40, which means that it's going to be on this side of the tree. 80 is greater than 60, which means it's going to be in this child. And since we're always inserting into a leaf node, well, we found our way down to a leaf node, and there's room in this leaf node, so we can simply add 80 to this existing node of the tree. The next value we insert, 90, is also going to fit into this same node. Except, of course, there's no room for it, which means that we're going to have to take the middle of the 3 values once again and push it up. So 80 is going to be pushed up into the parent. The value on the left will stay where it is. The value on the right, the greater of the 3 values, 90, is going to be moved into this new node that we create for it. And when 80 gets pushed up into the parent, well, this node over here is now going to have 3 children. And let's just redraw it to make it clearer that, in fact, this is going to be less than 60. This value here is going to be between 60 and the value we've pushed up, which is 80. And this child over here contains value greater than 80, which is 90. So the last value we insert, 100, is going to be an easy one. 100 is greater than 40, 100 is greater than 80, and 100 fits neatly into this existing node over here. And now our 2-3 tree is complete.